Uoči pandemije, rata u Ukrajini, energetske krize i stagflacije, stigle su najave da će velike evropske kompanije, naročito njemačke, zbog sve nepovoljnijih uslova na azijskom tržištu, proizvodnju vraćati na stari kontinent. Prilika je to za sve male nacije, naročito one sa industrijskom tradicijom. A kada govorimo o industrijskim korijenima Evrope, sasvim je opravdano našu priču započeti u Češkoj Republici. Gledate Al Jazeera Business Specijal koji u potpunosti realizujemo u ovoj zemlji. Moje ime je Jakov Avram. Ostanite s nama. Institut za informatiku, robotiku i kibernetiku u Pragu jedan je od relevantnih istraživačkih centara u evropskim okvirima. Ime su stekli saradnjom sa velikim svjetskim kompanijama, a one do njih, kako kažu, nisu došle slučajno.
I believe that it's a combination of various skills. So we have a strong background in traditional automation system and traditional robotics. So we are connected to Faculty of Mechanical Engineering that provides the core metal parts that are present in the industrial world, and we prove that we are able to speak in language that the industry speaks, but also the combination coming from informatics, artificial intelligence, and what we offer here is the combination of these approaches. We show how these very different worlds can be combined and actually can be the problems that appears in one system can be transformed in a system where existing solution can be applied. This is the case with the automated planning of robotic movements using automated planning system that were originally developed for different tasks. Let's start with Airbus. We started a cooperation in one European project. It was called ARUM, and it was focused on optimization of the ramp-up phase when a new type of aircraft is introduced, and there is strong need for fast reconfiguration and replanning of the processes because some troubles are found during the construction of the first units and first aircraft, and you need to find alternative paths not to block the whole production. So we solved the system and we created a system that is now used in practice, which does in the runtime rescheduling and replanning of the operation based on the current needs and possibilities of the workers that are present at production. And opening this cooperation, we also identify new potential usage. One is optimization of the whole supply chain. Use the same approach to plan and schedule work of the whole supply chain that delivers the parts to the final production, but also to simulate the future production already during the design of new models. It's called co-design, and you design the product together with the production system, and you identify possible difficult steps in the production, which is extremely important for Airbus, which production system is distributed all across Europe. And it's very good to identify the maximum size of a wing which you can transport from Bremen to Toulouse with no extra need for extra load. So it's very important to actually decompose the whole product in the parts that are not extremely difficult to manipulate, and this is the project we work on right now.
This is a research and development project where we are using an industrial robot and also the two-axis positioner for 3D printing, and we call it additive manufacturing. This process means that you are, adding a material and you are creating some objects in 3D. And the advantage of this workplace is that you can use the positioner and create objects without support and those objects could be normally printed with supports, you know, and this brings to the process the post-processing, you know, process, which takes a lot of time, and this is much faster, and also the printing space for this robot, for this robotic workplace, is much more larger. And you can see that it is equipped with like a basic extruder for the test purposes here. And now the robot is creating some calibration artifacts. And those artifacts are made that in one axis it changes the temperature of the printed material. In the second axis it changes the layer height of each layer. And in the z-axis it is changing the speed each 5 millimeters. So you can see that now it is changing, and like the result of this is these calibration artifacts, and they are used and analyzed. And with usage of neural networks, we are tracking the parameters, and like we are trying to find and predict the best process parameters for additive manufacturing.
This is a Delta robot. In fact, with a cooperation with the Recape, we created this Delta robot with a hand-guided controller. So this is a concept of mechanical programming of the Delta robot. So in fact, you don't need to have a software developer. You just can take the controller, show to the robot what it should do, and after that it's gonna remake it like fastly and probably more precisely thanks to the AI. So in fact there's the concept of the usage of the industrial 5G. So we are the first who used industrial 5G in for industrial purposes. So here, in fact, this is a Linux computer which streams the video to the server. And on the server, the neural network is computed. After that, it sends back the coordinates, and the result is showed here. So this is a concept of the usage, hand-guiding 5G and the server, and outsource of the mathematical computational tasks. So this is a concept. So this is a concept of the hand-guiding controller. So we just take the robot and we can move it like that. So you just pushing, and the robot is going to that direction which you want. And also here is a neural network which gonna detect the objects. So you don't need to have like some defined positions of the object, so it's gonna be taken from the picture. So this is a more advanced industrial way how to produce some products. So in fact you don't need to somehow specify the positions of those objects. So right now we're gonna show the kinematics showcase. So we need to close the door due to the safety reasons. So the Delta robot is a super precise and a super fast robot. Of course, there are some minuses or disadvantages. For example, that the working area is really small, but the pick and place process could be really fast and really precise. So in most cases, Delta robot is used for pick and place tasks. For example, here we have a case how to adjust the tire to the plastic disc, and right now my colleague gonna show the kinematic of this robot. So it's gonna ride just fastly on like some circles. So this is a showcase of these kinematics. So it's how it could be like fast, and you see that it's super powerful. Yeah.
Tomasz, how this RoboBar works?
So this workplace is based on the automation devices for the industry, and the idea is that two robots will prepare drinks for people. So we have here a coffee machine, we have here post-mix, also tap beer, and a conveyor with distillates and also with some syrups. And currently, the stage of this project, we can say that this is the best in the world right now, because a lot of RoboBars exist on the world, but they are like focused on let's say, separately to get the beer, or separately get the coffee, or separately get mixed drinks. But this workplace implements all those functions together, and it is just up to you what you want, and you can order, let's say, almost everything what you can order on a normal bar in or a restaurant.
So now, if I want a coffee, what should I do?
So you just, if you can take a look, there is like a screen which says order a drink. So you tap it, then you can choose what you want. This is like coffee and still water. So we can try to press it. Then you can see that the robot moved. You get the number of your
order. Right?
Of your order. It is similar like in some fast foods, because people are used to work with this. So we did it like that, and it is working pretty good. So now you can see that the robot is working on the preparation of coffee. I think it was espresso. Yeah, you can see it,
it is
on
espresso.
the screen.
Yeah.
This coffee machine is connected wirelessly, so it is working through some Home Connect protocol, and like our programmers implemented this protocol into the industrial communication protocol. So the whole robotic workplace is running on the industrial component on the programmable logical controller, PLC. And this provides us that the stability and the robustness of this system.
Češka spremno dočekuje četvrtu industrijsku revoluciju, kada će istraživačke institucije poput ove voditi glavnu riječ u nametanju trendova.
The future is that we will meet AI in much more situations than we are used to it, and we won't be aware of actually dealing with systems that are empowered by AI. The future AI will be typical for not be easily observable by humans. So, for example, in the new generation of chatbots are reaching the level that the humans have difficulties to recognize that the system they are talking to isn't a real human, but it's a AI-driven automatic system. Currently, the main drivers are coming from sustainability projects. The traditional mass production is something that can be covered by well-developed automated systems, and there's a long tradition of having efficient mass production system. But if you need to do high quality retrofitting, disassembly for recycling and for reuse, already used systems, you need to have a system that is able to recognize the current state of the system you want to retrofit. It needs a flexibility to cover the various possible situations, and there the AI empowered solutions are necessary. Typical example, we just signed today a contract with a company from Slovak that is focused on retrofit of batteries from electric cars. It's automated disassembling of batteries from electric cars, automated identification of state of individual modules that creates the whole battery, and reuse of the promising modules for further application. You can't do that without strong AI solutions that use computer vision to identify the screws which can be in various conditions after years of being used, then grasp the modules automatically by grippers, bring it to the testing line where you do the test, and then you automatically store it into a warehouse system from which you can use it to build the second life batteries. So this is a nice example where the future, and what is the future that AI in industry opens.
I think that the robotics are the real future, long-term future of Microsoft. I think what I mean by that, if we're talking about 20 years down the road, I'm not talking about next 5 years. But what we do with robots is that we developed, today when you look around robotics, there are present in two areas. And one area is manufacturing, right? These big robotic hands that in car manufacturing and so. And then you have also like robotic cameras that watch the quality on a production line. What we've done is something different. We've done a smaller robot, much cheaper, like in order of a magnitude cheaper than the big manufacturing robot. We also built in cameras, and we use it for two different purposes. The first purpose is QA on embedded systems. So we have a lot of embedded electronics today, but you cannot automate your QA, your quality control, just you can on web page. Because if you have like traditional software, there are a lot of tools that automate your testing. But if you have a physical device with display, you can't. So our robot is actually executing test scenarios. And then we have camera. We also invested a lot in what's called AI, or I would call it more computer vision, neural networks. And we determine which screen you are at, what are the objects on the screen, whether the test case was success or fail. The robot can recover from different types of error on that device. So quality control on embedded systems. And the way how it started was that we needed to do this quality control for ourselves on printers, copiers, 3D printers, even mobile phones for a mobile app. And then we thought, well, if we need this, maybe others need that as well. So we have customers from automotive who would use our robots to test their infotainment systems, for example. So there are plenty of opportunities on really, and that's really software development for embedded systems. And that's one area. And the other area is what's called RPA, robotic process automation. That's a big market, but however the name says robotic, it actually means software only. RPA, robotic process automation, is a piece of software that actually sort of simulates a human being, simulates mouse and keyboard, and it pretty much fills in data on behalf of a human based on some data inputs. And our robots are used to extend that RPA to the physical world. So you receive an order, your software RPA creates, from PDF, creates in your ERP physical order. And our robot touches the screen on your manufacturing line, creating the real order to produce that physically.
Kompanija Ysoft već dugo je među liderima na svjetskom tržištu softvera za 3D printere, iako posljednjih godina pokazuju sve veći interes za robotiku. Osnivači su se upoznali tokom studija u Brnu, gradu koji se u proteklih nekoliko decenija prometnuo u Evropski tehnološki centar, ili kako ga mnogi nazivaju, češku Silicijsku dolinu.
We founded Ysoft back in 1998, just students that were doing software development pretty much to hire, custom software development. And we try to do a lot of different things over the next 5 years. So 1998 till like 2003. And the interesting thing about that period was that everything we tried sort of failed. We knew that we would prefer to work on a product, something that we own, that we nurture, that we develop all over the time. So we didn't like jumping from one project to another. But all projects we tried was just not a disaster, but a failure, usually from a marketing standpoint or something like that. And the important takeaway from that period is just don't give up, right? And we had very strong motivation to succeed. One of the drivers back then was to show our parents that they were wrong because they predicted that we are going to fail. And they said, you shouldn't be entrepreneurs. You should finish your university, get your degree, get a good job in an international company, and when you're 40, you can become CEO or something. And we had our own path. But it was not easy, and that motivation helped us to overcome these beginnings. And then in 2003, after 5 years and 6 different tries, we came with a product called SafeQ. And that was print management. Back then, it was a print management software that allowed to securely pick documents on a printer based on your card authentication. And since then, the company started to grow.
Uprkos značajnim rezultatima evropskih kompanija u oblasti naprednih tehnologija, Muhna smatra da je taj sektor i dalje u sjeni konkurencije iz SAD-a i Južne Koreje. Nije optimističan i da bi se još zadugo nešto moglo promijeniti, i to ne zbog manjka znanja ili želje za razvojem, već društvenih i političkih problema duboko ukorijenjenih širom starog kontinenta.
I think Europeans are trying hard, but with all the respect, even to my own company, we are by far not as successful as our counterparts from, for example, US. I think that one of the reasons, especially in the US, is it's a much bigger market. I mean, we have our European Union market, but the market is not really a single market. In many areas it is, but you have a lot of issues that are much more difficult to handle. For example, VAT, or maybe telco is regulated a whole lot more, and so on. And then we have so many different languages. And some countries would really require your physical presence, where you don't have all that in the US. So if you're a startup in the US, on the local market, you can scale much faster. And the same would be in China, right? Again, much bigger market where you can scale much faster because you have one country, one language. Yeah, in the US you have sales tax, but the thing is that, for example, in the US, if you want to sell physical goods across all the different countries, you have a multitude of providers who would handle all that regulation for you. In Europe, it really doesn't exist, right? So I think that's one of the reasons. And the second reason, I think it's immigration. When you look at Silicon Valley in the US, how many Native Americans you'll find there? I mean, I'm not saying zero, but it's negligible. All of the people there are brains from all around the world. You have successful Czech companies, you'll find them in the Silicon Valley. Indians, Japanese, Chinese, you'll find, whoever is really successful goes there. Because, well, they have the ecosystem, but they are also much more open-minded to immigration, pretty much. And in our countries, Central and Eastern Europe, our citizens don't react real well, and they struggle to differentiate whether we have a Syrian refugee with PhD or someone whose motives are real economic. And for many people here, it's just Syrian. We don't want that person, and I think that's another disadvantage that limits the number of brains we can get into our countries.
Gledali ste Al Jazeera Business specijal koji smo u potpunosti realizovali u Češkoj Republici. Hvala na pažnji i doviđenja.